Very good. 12 times 4. Very good. Nice job.
Yeah.
I know you're going to find it difficult to annotate, but just keep on. You will get used to it. Good. Very good. I love this. Nice.
Sure. 12 root 2.
Very good. But do you know that this is not the final answer? Do you know that?
Oh, yeah. Yeah.
The answer you got, did you just write 12 root 2 or 2 root 12?
12 root 2.
No, it can't be 12 root 2. Do you know why it can't be 12 root 2?
Oh, sorry. 2 root 12.
Or 2 root 12, right? Very
Yes,
good.
sir.
So 2 root 12. But do you know that root 12 can further be simplified? Do you know that?
Yes,
Root
sir.
12 can further be simplified. So if you have root 12, remember you got 2 root 12 as your answer. 2 root 12, right?
Yes. Yes, sir.
And you know that root 12 too can also be further simplified by you saying this is 2 times root 4, right? Root 4 times root 3, right?
Yes, sir.
So this is going to give us 2 times 2, which will give us 4. Because root 4 will give us 2 times root 3. Right? So our answer will be 4
Yes.
root 3. Have you seen it now?
Yes, sir.
Very good. So our final answer is 4 root 3. So when it comes to simplifying sword, you must be very, very careful. You must be able to look out for factors that will give you a perfect square when you're multiplying. You must be able to simplify most of these factors. It says here, break down the numbers under the root into prime or perfect square factors. It's very, very important because if you're unable to do that, you might find it difficult when it comes to doing other operations in what? Sword. Okay?
Yes, sir.
Okay, so let me give you one more. Because me, I love to ask questions a lot so that I will be able to know if you understand what you just did. Okay, so be ready for questions, questions, questions. If you're not asking me a question, I'm going to be asking you questions. Okay? Okay, so
Yes,
let's
sir.
go. It says simplify root 72. Can you simplify root 72 for me? Root 72.
Okay, sir.
Yeah.
Yes. Uh,
That's fine. Very good. Very good.
sorry. Can I continue
Okay.
here?
Yeah, you can continue. Yeah, you have the whole screen to yourself to continue. Just keep on writing. So what's your answer?
6 root 2.
6 root 2. Excellent. Good job. Good job, Dan. John, good job. So you now understand how to simplify sword, right?
Yes, sir.
Okay, very good. Because this is just like a let's say simpler part of what sword, simplifying sword. Because right now I'll be going to the next slide. Okay. Let me just
Yes,
wipe
sir.
off the screen so that we're able to see the next slide. Okay. So it says here, since we've already learned how to do what simplify swords now, we know what sword is, we know the types of sword we have, and we know how to simplify swords now into a more comfortable and simpler word form. Now we'll be looking at arithmetic with swords, addition and subtraction, of sword. This is where it becomes a little bit tougher. Okay? Well, I'm sure you know
Yes,
it already,
sir.
right? Okay, beautiful. It
Yes.
says here that only like swords can be combined. Do you know what they mean by only like swords? Can you tell me what they mean by only like swords?
Uh, Sorts of the same that don't have first roots in front, a first number in front of the roots.
Okay, swords that have what do you mean by
That
that?
have the
You know
same
you're touching your beard.
number
The same
before the
roots.
roots.
Oh, no, 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 no. I won't agree with you with that. Rather, what you have said is numbers that have the same roots. It's just like you saying, imagine if I should give something like this now. If we're to go to what they call it now, algebra, and I give something like this now, 2x plus 3x. What is 2x plus 3x? What would that give you?
5x.
5x. Why were we able to add this particular
Because,
expression
because
together?
they both have x.
Yes, very good, because they both have the same like terms, which is the variable x. Imagine if I should now give you 2x plus 4y. What will be your answer?
It's so still the same.
It's still going to be the same. Very good.
Yes.
Very smart of you. It's still going to be the same because there's no way we can add these two variables together because they're not like terms. Okay?
Yes.
So now roots that have the same, sorts that have the same roots are addable. You can add them, you can subtract them. Let's have a look at the example here. We have 3 root 2 plus 4 root 2. 3 root 2 plus 4 root 2. So that 3 in front of the root is just like a coefficient. You know, if it's in algebra, we call it coefficient. A
Yes.
number in front of a variable is known as what? A coefficient. So 3 root 2, 3 root 2, that number 3 is just serving as a what? Coefficient of root 2. So we're going to be adding the coefficient of the roots since they are the same together. So what is 3 plus 4 root 2? 3 root 2 plus 4 root 2, that will give us 7
Root.
root 2. Okay?
Yes, sir.
So this is very, very easy when it comes to addition of roots and subtraction of roots. This is just like I said before, a pre-class. Okay? Because you'll be seeing more
Yes,
complex
sir.
question than this. The same thing with multiplication of roots. If you look at multiplication of roots, we have root 2 times root 3 will give us root 6. Roots of
Yes.
the same kind, once you multiply them, they give you root 6. So if I should give you something like root 7 times root 9, what would that give you? Root 7 times root 9.
Root 21.
Root 7
Um,
times root 9.
root 7. Oh, sorry. Root 81.
Root
Root
80,
61. Root 61.
root
Root
63.
63. Root 63.
63. Very good. So we're having 7 times what? 6 will give us what? Root 63. So John, we'll have to be stopping here right now because our time is up. I'll be going over now to teach your brother. As I said before, this is just like a preparatory class, an introductory class for us to get to know you better and know your strengths. Okay?
Yes, sir. Okay, sir.
Okay, very good. So we'll be ending the class now. Your English tutor is already here already. and I'll be
Okay,
going
sir.
over to meet your brother.
Okay,
Okay.
sir.
So thank you very much. It was nice meeting you, John. Do have a lovely day.
Same, sir.
Yeah.
Uncle Sam, can you
Auntie
please take
Abby, you can
feedback
take over.
to the math class when Uncle Chigo's class will hold, please? Thank you.
Okay, I'm working on that already. I think you have to go back to the breakout class.
Yes, please.
Please. Okay, John is asking. John is the only one.
I'm supposed to move into James' class
We
now.
need to take Uncle Chigo and I to James's class.
Yeah.
To John's class, please.
Okay. James,
Hello.
how are you doing today, James?
Good.
Okay. I would love to see your face, James.
Hello.
Okay. Hello, James. How are you doing?
Good.
Very good. I'm Mr. Chigozie. You can call me Uncle Chigo. I'm Mr. Chigozie. You can call me Uncle Chigo. Yeah. So I will be your math tutor. I'll be your math tutor. Okay?
Yeah.
Okay. I would love to know you more. Can you just introduce yourself to me? Let me get to know you.
My name is James. I'm 14. My birthday is April.
Okay.
I like to play
Wow.
football. And my best food is pizza.
You said your best food is pizza.
Auntie,
Yeah.
you have to go back.
Oh, okay, beautiful. I
You have
did.
to go back. Not
So
allowing
you
you.
love pizza. I
Join,
love pizza as
somebody
well.
join back,
So
Auntie Abby.
what brand of pizza do you like? Is it macaroni pizza? Is it cheese or
I like pepperoni.
Pepperoni.
sorry?
Pepperoni.
Pepperoni cheese. Oh, so you love a lot of pepper.
Yeah.
Okay, very good, very good. Okay, it is nice to meet you. I'm Mr. Chigos, as I said earlier on, or you can refer to me as Uncle Chigo. I'll be your math tutor, taking your maths. If I'm right, you said you're in what class? If I'm right, you're in year one.
No, I'm second year. I'm going to third year.
Okay, in your second year, going to third year.
Yes.
Yeah.
Okay, so if we're to bring that to Nigerian standard, you're in JSS2 going to JSS3.
Yeah.
Okay, okay, beautiful, beautiful, beautiful. You're not a big boy. You're not a big boy. I like that. Heading over to Genesis 3. Okay, nice one. As I said before, our ground rules I'm sure that Auntie Abba must have told you the ground rules are English tutor.
Yeah.
Okay, very good. You know that you have any questions, you use the reaction emojis. Yeah, if you want to ease yourself, you let me know.
Yeah.
Okay. I love children who do the assignments. You must
Yeah.
always do your assignments. Okay. If you have any question, you feel free to do what? Ask me. Okay. We're always here
Yeah.
to do what? Answer you. Okay.
Yeah.
Okay. Very good. So, I'm sure you love mathematics a lot, right? You love maths.
Eh, I'm okay with it.
You're okay with it. Wow. You know, when I just saw your face, I thought you're a maths guru. It just came to me that you're a maths guru. So don't worry about that. Um, Maths is fun. It has been made easy. You understand? With our
Yeah.
help, you will enjoy mathematics, okay?
Yeah.
Very good. I'm going to be sharing my screen with you. We're not going to be talking much today. This is just like an introductory class. We'll
Yeah.
just be going through some few things and not much, okay?
Yeah.
Okay, so today, I just want us to look at this. You've been taught a number basis, right?
Yeah.
You've been taught number basis, right?
Number bases.
Yeah.
I don't think so.
Oh, you've not been you've not been taught number basis.
No.
Okay. But you've heard about binary numbers.
Yeah.
Okay, so when you're talking about number-based conversion, we're talking about converting different bases to another base. Once you see a number-based conversion, what should come to your mind is binary numbers. You know, binary numbers are numbers that are in base 2, right?
Yeah.
Very good. Binary numbers and numbers in base 2. We have base 3 numbers, base 4, base 5, base 6, base 7, base 8, base 9, base 10. We have base hexadecimal numbers and all that, because as you proceed in class, you'll be learning about all these numbers. You'll be learning a lot about all these numbers, okay?
Yeah.
Okay, so if you look at your lesson objective, it says there identify different number bases. The number bases you should know are numbers in base 2, base 8, base 10, and base 16. And at the end of the lesson, you should be able to convert numbers from one base to another and
Yeah.
solve problems involving number-base conversion. Okay?
Yeah.
Okay, very good. As I said before, when you're talking about number bases, what comes to your mind is how many digits does that particular number base have? How many digits does that particular number base have? So if we're talking about binary numbers, can you tell me the number of digits a binary number have?
Um.
Sorry?
1.
You said 0, 1, 2?
Uh.
You know what? When you hear binary, what comes to your mind is binary. It's not coding. Is it not we're trying to code, we're trying to do this, we're trying to do that, right?
Yeah.
Yeah. Do you know this movie Matrix?
No.
Okay, you don't know the movie Matrix. Okay. Okay, because if you've watched the movie Matrix, Matrix is telling you more about binary. You know, computer always understand one language. And what is that language?
Binary.
Thank you very much. So if computer understand binary numbers, now tell me how many digits are in binary numbers?
1.
One and what?
9 or
One and zero. One and
0.
zero. Nice attempt, one and zero. So when you're talking about binary numbers, which is base 2 numbers, what should come to your mind is zeros and one. Zero and what? One.
1.
Very good. Zero and what? One.
1.
Any number above that, just know that that number is no longer a binary number. Okay?
Yeah.
So example of binary numbers, I was teaching your brother how to annotate on the screen. Do you know what it means to annotate?
No.
It means for you to have the ability to write on the screen. You can see what I'm writing right now.
Yeah.
Very good. If you look at your tools, you'll be seeing where we have annotate. You should be on your screen where you have annotate, or if you don't see that, you see like a pencil sign that where you can annotate. Once you click on it, you will have the ability to write on the screen. Have you seen it?
Um. I only see notes and whiteboards.
You only whiteboard and what?
Notes.
And notes you're seeing.
Yeah.
Okay, you don't see anything like a pencil sign.
No. Oh yeah. Oh yeah.
You don't
Actually,
see
yeah.
that like it could be you've seen it. Okay,
Yeah.
click on it and try to write on the screen. Let me see. Click on it and try to write on the screen.
Um. Yeah.
I've not seen anything you've written.
I wrote on the
You wrote
left.
something. Okay, but
Yeah.
okay, can you write close to where I wrote 23? The
Oh.
number 23? Yeah. Okay, beautiful, beautiful, beautiful. Beautiful. So right now you've learned something. You know how to annotate right now. I
Yeah.
love that. Very good. Okay. So as I was saying before, binary numbers always consist of zeros and what? One.
1.
Zeros and what? One.
1.
And examples of binary numbers include, I can have something like this: 1, 0, 1, 101 base 2. 101 base 2 is an example of a binary number. 101 base 2. Another example of binary number is 1, 1, 1, 1 base 2. You can see. Another example of binary number is 1, 0, 1, 1 base 2. What do you notice in these examples I'm giving to you? You can see that it's only zeros and 1 that are included.
Yeah.
If I should give you something like this now: 1, 2, 1, 1, 2, 1 base 2. Is this an example of a binary number?
No,
Why is it not an example of a binary number?
because it has a different number than 1 or 0.
Very good, because you have a number that is higher than or exactly 2. In that what example, 1, 2, 1. Remember, the rule says you mustn't have number above or exactly that number you're working with. It should be below. So what you should be seeing is zeros and 1. No other number apart from that for binary. Okay?
Yeah.
The same thing goes with other base numbers, like base 3 now. What are the numbers that you're meant to be seeing in base 3 numbers? You know base 3? Base 3 numbers, what numbers will you be seeing? Numbers that are below 3, right? And what are the numbers below 3? What are the numbers below 3?
2, 1, 0.
0, 1,
2.
and 2. Very good. 0, 1, and 2. Very good. You see this now?
Yeah.
What about base 4 numbers?
3 and 1, 0, 1, 2, 3.
Very good. What about base 7 numbers?
0, 1, 2, 3, 4, 5, 6.
Very good. What about base 10 numbers?
0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
Good. And I told you that you're a maths guru. You don't want to believe me. You're a maths guru. Are you not the one answering the questions right now? That is good. So you can see, when you're talking about any number base, just know that those numbers that will be involved will be below the base you're working with. Okay? Will be
Yeah.
below the base you're working with. That's why I wrote here base 10 number, which is our decimal. Base 10 numbers are also known as our decimal numbers, which are the numbers we are using right now. Our 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We use all these numbers in our everyday life. Base 10 numbers. Base 2 numbers, we know we talked about base 2 numbers, only the digits 0 and 1, right? Only digits zeros and 1 for base 2 numbers, which is
Yeah.
used by the computer, right?
Yeah.
Look at base 8. Base 8 is also known as octa. So once you hear the word octa, you're talking about base 8. Octa numbers, base 8, just like from the word octopus. You've seen an octopus, right?
Yeah.
Have you eaten an octopus?
No.
You don't like seafood?
No.
Okay, you don't like seafood. Okay. How many tentacles does an octopus have?
8.
8. Very good. So the word octa is gotten from the word octopus. 8, base 8. And numbers between base 8, numbers that can be shown in base 8 are 0 to 7, right?
Yeah.
Very good. Now, base 16, which is known as hexadecimal. Once you don't say the word hexadecimal, we are talking about base 16. Okay?
Yeah.
That one is a little bit more complex, which you'll be learning in your GSS 3. Hexadecimals. They range from 0 to 9. They range from 0 to 9 and from 11 to 15. 0 to 9 and from 11 to what? 15. But now, the only thing there that for hexadecimal, your number 10 11, 12, 13, 14, 15 are represented with a letter. We just don't write them like that. We represent them with a letter. So for hexadecimal, we have numbers ranging from 0 to 9. Then number 10 in hexadecimal is written as what? Letter A. Capital letter A. Are you seeing this?
Yeah.
Number 11 is written as capital letter what?
B.
B. Number 12, yeah, is written as what?
Capital letter C.
Can you tell me what 12 will be written as?
C. Capital letter C.
Very good. 13.
Capital letter D.
Very good. 12 will be written as. Very good. 14.
Capital letter E.
The number 14. Very good. And number 15.
Capital letter F.
Very good. Correct. Capital letter F. That's why if I want to give an example of an hexadecimal number or a number in base 16, I can give you this example by writing, example of a base 16 number is A, 3, F, base 16. Are you seeing this now? A3F base 16. That's an example of an hexadecimal number. Okay?
Yeah.
Can you give me your own example right now? Can you help me write on the screen? Let me clean the screen for you so you'll be able to write.
Okay.
Okay. I would love you to give me your own example right now of a base 16 number. Can you give me an example? You can write now.
B. 4.
Okay.
C. Base 16.
Base 16. Thank you. B4C base 16. That is a very good example of an hexadecimal. Now let me test you. Are you ready?
Yeah.
Can you give me an example of a base 10 number? Base 10
Okay.
number. Yeah.
3. 5.
Okay.
9. Base 10.
Beautiful. Nice job. Nice job. Nice job. You can see you're already getting to that level of a guru in maths. Let me test you again. As I was telling your brother, I was telling your elder brother that I love to ask questions. So you'll be expecting much questions from me. Okay?
Yeah.
So let me test you one more time. Can you give me an example of an octa base 8 number? A base 8 number. Give me an example of a base 8 number.
2, 0, 7, base 8.
Beautiful. Beautiful. Nice job. Nice job. Nice job. The last question. Can you give me an example of a base 3 number? Base 3 number.
0, 1, 0, base 3.
Correct. Nice job. Nice job. Nice job. I'm very, very happy now you understand what number bases are, the
Yeah.
type of number bases we have, and you can now give me examples of number bases. Very good. Excellent job. Excellent job. Okay?
Yeah.
So let me clean the board because we'll be going to the next slide right now. So since you can give an example of all these number bases, now we'll be going to the next thing we need to learn, which is the actual conversion. How do we convert? How do we convert from one base to another? How do we do that? Now, you need to understand something. When it comes to conversion from one base to another, we must pay attention to some things, okay?
Yeah.
We must pay attention to some things. Now look at the screen. It says convert from base 2 to base 10. converting from base 2 to base 10. Now, I want to let you know that when you're converting from any number to base 10 is just like the general number system for everything. For every number system, base 10 is just like the general number system for every number system. Okay?
Yeah.
Very good. So if you're converting a particular number, be it base 2, base 4, base 3, base 7, base 9 to base 10, you must always use what we call the expansion method. You must always use what we call the what? Expansion method. And this is what is done on your screen right now. Right now, we're converting from base 2 to base 10. So since we're converting from base 2 to base 10, we use the expansion method. And I'm going to explain to you how we did it on this screen right now. Are you ready to learn?
Yeah.
Very good. Now, watch closely and listen up. As I said before, sometimes we'll be using our whiteboard. Sometimes we might even be using slides. Okay? So
Yeah.
now, what they did right here, they're trying to convert 1101 base 2 to base 10. As I said before, we'll be using expansion method. Okay?
Yeah.
So in order for us to do that, the first thing we need to do, we must first multiply all the numbers we have here by the base we're working with. So we're going to be multiplying 1 times 2, 1 times 2, 0 times 2, and 1 times 2. So we'll be taking it gently. So we're going to start with 1 times 2. Are you seeing it? Plus,
Yeah.
we go to the next number again. 1 times 2
2.
plus, we go to the next number again, which is 0, right? 0
0 times 2.
times 2. And we go to the next number, which is 1 times 2. Are you seeing this now?
Yeah.
Now, once you've done this, now, the next thing you need to do now is to put our powers. You can see there are powers on top of these two, which, right? There are powers
Yeah.
on top of them. So how do we do that? We start from the back and with the number 0. So they're going to be adding 0 to this. It's going to be 2 raised power 1,
First
2
power
raised
2.
power 2, and 2 raised power 3.
3.
Are you seeing this?
Yeah.
Yeah. So once you've done this right now, once you've done this, you can now do what? Start simplifying. Remember, you know what is 2 raised power 3? You know what 2 raised power 3 means?
2 times 2 times 2.
And that will give you what?
8.
8. Very good. So what is 8 times 1?
8.
Very good. 8. So this is 8 plus, what is 2 raised power 2?
4.
4. What is 4 times 1?
4.
Very good. Now remember, if you look at this one, 0, you know that 2 raised power 1 will give you 2, right? Now 0 times 2 will
Yeah.
automatically give you 0.
0.
Because any number multiplied by 0 will give you what? 0. Very good.
0.
Then the last one. Yeah. What is 2 raised power 0? 2 raised power 0?
0.
You know what 2 raised power 0 is?
0.
2 raised power 0 is not 0.
No.
2 raised power 0 is
It's
1.
2.
Yeah. 2 raised power
1.
0 is 1. Yeah. Any number raised to the power of 0 will eventually give you what? 1.
1.
Any number, as I said before, any number raised to the power 0 will eventually give you what? 1.
1.
And this will give you what? 1.
1.
If you add this up, because 2 raised to the power 0 is 1, 1 times 1 will give you 1.
Yeah.
So if you add this up right now, we'll be having what? 13. 13. So this is how we do expansion when we're converting from one base to another. Okay?
Yeah.
Very good.
Yeah.
I hope you understood this.
Very well.
As I said before, this is just like a great, very good. I like that. So this is just like a introductory class. When we start our normal classes, you'll get to learn more,
Yeah.
okay? Our time is up already. Our time is up, and I
Okay.
have to let you go right now, okay? So
Okay.
in our next class, we'll be discussing more about this, okay?
Okay. Thank you.
So thank you for having us right now.
Thank you.
Yeah, and have a lovely day. Bye.
Bye.
Okay, we can all go to our classes now. So Amanda is not in class. Gerard is not here yet.
Hello, Darren.
Hello, Chimamanda.
Hello. How are you doing today?
Good.
Great. Like the brightness of your smile. Okay. All right. So today I'm also going to smile.